Hello everyone and welcome back. In this video, we're gonna take a practical journey through quantitative inquiry using one of the most commonly used statistical tools in research, SPSS. More specifically, we're gonna explore how researchers analyze income by gender using descriptive statistics and the SPSS Explore command. Now, if you ever looked at statistical output and through it seemed overwhelming, don't worry. By the end of this video, you will understand not only what SPSS calculates, but also why those calculations matter and how researchers interpret them to make evidence-based conclusions. We'll discuss variable measurement levels, descriptive statistics, distributions, histograms, box plots, stem and leaf plots, skewness, characteristics, and the impact of extreme scores and statistical interpretation. Whether you are a doctoral student, researcher, analyst, professional, or simply interested in understanding data more effectively, this video will help you see statistics in a practical and meaningful way. So let's jump right in. Quantitative inquiry, income analysis by gender using SPSS. Let's begin by discussing the purpose of this analysis. The goal is to examine income differences between groups and understand how statistical tools help us describe and interpret those differences. One of the most important concepts in quantitative research is that data tell a story. However, before we can understand that story, we need to organize, classify, and analyze the information properly. This is where SPSS becomes valuable. SPSS allows researchers to summarize large amounts of information and identify patterns that would be difficult to recognize by simply looking at raw numbers. In this example, we're analyzing income distributions by gender. The purpose is not simply to compare averages. The purpose is to understand how income is distributed, how scores vary, and whether certain statistical characteristics influence interpretation. Throughout this video, you'll see why understanding distributions is often more important than simply knowing the average. Let's see variable view, understanding your data. Before any analysis begins, researchers must define variables correctly. This step is often overlooked, but it is one of the most important parts of the entire research process. In SPSS variable view, every variable must be assigned a measurement level. In our example, gender is a categorical variable. Income is a numerical variable. Researchers must determine whether variables are nominal, ordinal, interval, or ratio, because that classification affects which statistical procedures are appropriate. Gender functions as the grouping variable. Income functions as the outcome variable being analyzed. If variables are classified incorrectly, researchers may select inappropriate analysis and reach invalid conclusion. Think of variable view as building the foundation of a house. If the foundation is weak, everything built afterward becomes questionable. Proper classification ensures valid results and accurate interpretation. Here we go, levels of measurement. Now let's discuss the four levels of measurement. Nominal variables represent categories without any meaningful order. Examples include gender, department, occupation, or program membership. Ordinal variables contain categories that have a meaningful order but unequal distances between categories. Examples include rankings, satisfaction ratings, and Likert scale responses. Interval variables contain equal intervals but no true zero point. Temperature measured in Celsius is a classical example. Ratio variables contain equal intervals and a true zero. Income belongs to this category. Age, height, weight, and salary are also ratio variables. In our analysis, gender is nominal. Income is ratio. Because income is a scale variable, we can calculate meaningful averages, variability measures, and distribution statistics. Understanding measurement levels helps determine which statistical procedures are appropriate and defensible. Let's discuss SPSS analysis recommendations. Now, let's talk about selecting the appropriate analysis. One of the most common mistakes researchers make is using statistical tests before fully understanding their variables. The choice of analysis depends on the research question. If researchers want to compare average income between two groups and independent samples, t-tests may be appropriate. If there are more than two groups, a one-way ANOVA might be considered. If researchers want to examine relationships between continuous variables, correlation may be useful. For prediction purposes, regression analysis often becomes appropriate. However, before conducting any inferential statistics, researchers should first perform descriptive analysis. This is exactly why the explore command is so valuable on SPSS. It provides a comprehensive understanding of the data before advancing testing begins. Good statistical analysis always starts with understanding the data. Let's deep dive into descriptive statistics, what they tell us. Descriptive statistics summarize the characteristics of a data set. Think of them as the first layer of interpretation. The mean represents the arithmetic average. The median represents the middle value. Quartiles divide the distribution into four equal sections. Range measures the spread between the highest and lowest values. Variance measures overall variability. Standard of deviation indicates how much scores tend to deviate from the average. Skewness measures asymmetry. Cortesis measures tail heaviness and the presence of extreme values. Together, these statistics provide a detailed picture of the distribution. Researchers use them to understand central tendency, variability, and distribution shape before making broader conclusions. Let's see how to compute the statistics using Explore. The Explore command simplifies the process considerably. Researchers begin by selecting Analyze. Next, they choose Descriptive Statistics and then Explore. The income variable is placed in the dependent list. Gender is placed in the factor list. Within the statistic options, researchers select descriptive measures. Within the plots options, researchers request histograms with normal curves, box plots, and stem and leaf plots. Once the analysis is run, SPSS generates extensive output. This output provides both numerical summaries and visual representations of the data. The combination of numbers and graphics helps researchers understand patterns more effectively. Let's see descriptive results, income by gender. Now let's examine the actual findings. The average income for males was approximately $34,000. The average income for females was approximately $27,000. At first glance, this suggests males reported higher average income levels. The median income for males was approximately $32,000. The median income for females was approximately $21,000. Notice that the means are higher than the medians for both groups. This immediately suggests the presence of higher income observations, pulling the averages outward. The quartiles provide additional insight regarding how income is distributed across each group. These findings demonstrate why researchers should never rely solely on averages. This distribution tells a more complete story. Here is the understanding the Explorer plots. One of the strengths of the Explorer command is visualization. The output includes histograms, box plots, and stem and leaf plots. Each plot serves a different purpose. Histograms reveal the shape of the distribution. Box plots identify spread quartiles and potential outliers. Stem and leaf plots display actual data values while preserving the distribution pattern. Visualizations often reveal information that numerical statistics alone may not fully communicate. Researchers use these graphics to verify assumptions and identify unusual patterns. The combination of statistics and visual analysis produces a stronger understanding of the data. Let's see histograms with normal curves. Let's focus specifically on histograms. A histogram shows how scores are distributed across different intervals. The normal curve serves as a reference point. If the bars closely follow the curve, the distribution may approximate normality. In this analysis, both income distributions display positive skewness. Most observation cluster toward lower and middle income levels. A smaller number of high income observations extend the distribution toward the right. This pattern creates a longer right tail. The female distribution appears even more skewed than the male distribution. Histograms make these patterns immediately visible. This is one reason visual inspection remains an important component of quantitative analysis. Here are box plots and stem and leaf plots. Now, let's examine the box plots. Box plots provide a concise summary of distribution characteristics. The box contains the middle 50% of observations. The line inside the box represents the median. Whiskers indicate spread. Points beyond the whiskers often represent potential outliers. In our example, outliers appear in the upper income ranges. These observations contribute to positive skewness. The stem and leaf plots reinforce this conclusion. Scores extend further toward higher income values than toward lower values. This pattern confirms the presence of right skewed distributions. Together, these plots provide strong visual evidence regarding the shape of the data. Here are skewness and kurtosis interpretation. Now, let's answer one of the most important questions. What can we determine from skewness and kurtosis relative to a normal curve? Skewness values greater than zero indicate positive skewness. This means the distribution contains a longer right tail. In practical terms, most people earn lower or moderate incomes, while a smaller number earn substantially higher incomes. Kurtosis provides information about tails and extreme values. Higher kurtosis values suggest heavier tails and more extreme observations. The female income distribution demonstrated stronger skewness and higher kurtosis. This suggests more pronounced high-income outliers to the rest of the distribution. Compared with a perfectly normal distribution, both groups display departures from normality. These departures are important because they influence interpretation and statistical assumptions. We are at final interpretation and key takeaways. Let's conclude by answering the final questions. What are the mean and median? The male mean income was approximately $34,000, while the median was approximately $32,000. The female mean income was approximately $27,000. The median was approximately $21,000. Does the mean or median better represent the scores? In this situation, the median appears to provide a better representation of typical income. Why? Because the distributions are positively skewed. Extreme high income observations pull the means upward. As a result, the means may overstate what a typical individual earns. The median is less sensitive to outliers. It often provides a more realistic picture of the center of a skewed distribution. This example demonstrates an important lesson for every researcher. Never rely on a single statistic. Always examine descriptive measures, distributions, variability, and visualizations together. The most accurate conclusions emerge when multiple pieces of evidence are considered simultaneously. And that is one of the most valuable lessons quantitative inquiry can teach us. Thank you for joining me in this video. If you found this presentation helpful, be sure to like, subscribe, and share it with others interested in research methods, SPSS, quantitative analysis, dissertation research, statistics, leadership, and evidence-based decision making. And remember, data are most powerful when we look beyond the numbers and understand the story they tell. I'll see you in the next video.